there, and welcome to another episode of Mr. Powell Helps His Students with Math. I hope this helps you and gets you better on your journey to understanding this. All right, so here's the first one. First of all, learning target 10b, I will be able to add and subtract radicals. You can only put together like radicals. So I see 12 root 10 and I see 7 root 10. Since those are the exact same radicals, same number under the radical sign, we literally just add the 12 and the 7 together. So 12 plus 7 is 19, and we still have root 10. That's it. It's just like combining like terms. All right? So then when we look at this next one, we see a positive 2 root 6 and a negative 3 root 6. Well, that's a positive 2 and a negative 3 just combined to give you minus 1 and then square root of 6's. Okay, so that's it. Since root 10 and root 6 are not the same, you can't put them together. Okay, now here's the big thing about number 1. Number 1 had radicals that were already simplified, okay? But as we look at number 2, I need you to notice right off the bat that that's not the case. Root 24 and root 50 here can each be simplified. Okay, so that's the first thing we're going to have to do. So if I take my blue pen here and I just say, okay, that's 24, I'm just going to start towering 24. So 24 divided by 2, that's where I get 12. Divided by 2 is 6. Divided by 2 is 3. So first thing I got to do when I'm adding and subtracting radicals is to see if there are like radicals by simplifying the radicals. Okay, so while looking at this, I circle and cross, and I can't touch anything else there. So basically, out of this first root 24, we get 2 is circled, so it comes outside, and then 2 times 3 is untouched. That goes back inside. All right, but notice here, I was just simplifying the root 24. So I'm going to color code this so you can really clearly see this. There's still a 3 times root 24 out front. That 3 has to come down for the journey. So we really have 3 times 2 root 6. Again, the root 24 just became 2 root 6. We still have 3 times out front. And we'll take care of that in the next step. But looking now, okay, what do we have across here? I have literally just plus 5 root 2. And the reason I have plus 5 root 2 is because the root 2 is already simplified. But then, you guessed it, we have to take the 50 and try to simplify that. So you can do these, of course, faster. If you can see the perfect squares that go in, that's great too, but I'm showing the tower each time I do a video. So divide by 2 is 25, divided by 5 is 5. Now, careful, circle cross only the numbers that are in common. So 5 and 5 are gone. So what does that become? That becomes 5 on the outside, 2 on the inside. So minus 5 square roots of 2. And then on the back end here, we didn't have to simplify that at all, or we can't simplify that out, plus 3 root 6. All right, so now I don't know how fast you can see this, but clearly just look at this term here, plus 5 root 2 minus 5 root 2. Since those are like radicals, those are literally just going to cancel and be gone. So what we have left here is the 3 times 2, or the 6 root 6. That's what we have left there, plus on this end, a 3 root 6. And since those are like radicals, we can now put it together, and we have 9 root 6, and that's the final answer. All right, next one. Basically what I'm going to say on these is that when you multiply, remember outside with outside, inside with inside. So here we go. The 4 times the 6 makes it 24. Literally 4 times the 6, they're both outside number, makes it 24. Then we multiply that by the square root of whatever 3 times 12 is. Well, 3 times 12 comes out to be 36. Well, then we want to tower 36, but I'm hoping you're not going too fast to your tower, because 24 times root 36 is just 6. It's a perfect square, something we've known for a very long time. So when you take 24 times 6, you get 144, and that's our final answer to that problem. Okay? And then in this one, you should be distributing through. So here we go. Root 5 times 2 root 3. Well, the only outside number is a 2, so 2 times really a 1 here is 2. And then we have root 15. So 2 root 15, inside with inside. And then plus, depending on how you see this here, root 5 times root 4, we can just make them both inside numbers, root 20. But then we'd have to go to the side, or any way you're comfortable doing, we need to simplify the root 20. So that's a circle and a cross. So what we have here is 2 root 15 staying the same there, plus circle 2, untouched 5 goes in. Now, if you're wondering why I didn't simplify the root 15, just look at what it looks like. You divide by 3, you get 5. There's nowhere to go. These are not like radicals. You cannot do anything more than this. That's our final answer. Now look back up here. See this root 4? Some people will change that to 2 right away because the square root of 4 is 2. Then when the root 5 comes through, it's going to say 2 root 5, and you'll get there a little bit faster. All right? Okay, so now in this one, number 5, we need to FOIL that problem. So first would be 2 times square root of 2, so 2 root 2. Outside are both numbers that are outside, and they're both positive. Watch your signs very carefully when you do this. But then inside here, we have a negative 3 times 1, so negative 3. Root 2 times root 5 is a root 10. And then the last here is negative 3 times 6. They're both outside numbers, so negative 18. And then square root of 5. You cannot reduce any of these radicals. You cannot put any of them together because there are no like radicals. That's the answer. All right, so look at this one then. Final one here in the multiplication is we really have 5 root 2 times 5 root 2. That's what anything squared means. So you can rearrange this in your brain if that helps. That's really 5 times root 2 times root 2. Well, 5 times 5 is 25. And then root 2 times root 2 is the square root of 4. But we've also been working on that being root 2 times root 2 is literally just the number 2. So you get yourself down to 50 if you go through that process. Another way to think about this is literally like we did with the exponential rules. You could literally take 5 squared and root 2 squared, and all that becomes is 25 times 2, which also gets you to 50. So however you like to think about that. Okay, very important that you follow the process on these last ones. Rationalizing the denominator means no radicals in the bottom, okay? So do not put radicals in the bottom or you will get an angry face from your math teacher. That's sad, angry, I can't tell. Okay, so here we go. So 12 over root 3, we're going to multiply by root 3 over root 3 on this one. And on the top, we're going to get 12 root 3. And then on the bottom, root 3 times root 3 is root 9, which I really want you to get in the habit of making just 3 that fast. So now don't stop here. Some of you are stopping here. 12 divided by 3, that's a 4 over 1. So that simplifies all the way to 4 times the square root of 3. All right, so watch this. On this one, you are not wrong if you do this. Look at this, root 24 over root 24. You are not wrong if you do this. The bottom won't be that bad, but at the top, you're going to have 12 times 24. That's a large number, and it's going to be inside, so then you're going to have to simplify that radical. So what I'd really like you to do is to, if you can, simplify first. I mean, look at this problem. These are both outside, correct? So what can we do there? Well, we can make that a fraction with 2 over 1, just from the 6 over 3, because that's 2 over 1. Now also in here, look at this. 12 goes into 12 once, into 24 2 times. So what we have there is the square root of 1 over the square root of 2. Now remember very carefully, be careful to make them both in the house, okay? So look at this, we really have 2 times the square root of 1, that's a perfect square, which is 1, so that's just 2 over the square root of 2. All right? Well, a little bit of work to get us here, but it's not hard math, we're just simplifying fractions, and now the new part is to make sure we don't have that radical on the bottom. So we got to multiply by that root 2 over root 2. On the top, we'll get 2 root 2. On the bottom, you guessed it, we'll just get 2. Well, then we can clearly see that if we have 2 2's on the outside, they cancel off, leaving 1's. Final answer to this problem is just the square root of 2. Now remember, at the beginning I said multiply by root 24 over root 24. It is possible to do that. You'll get the same answer if you do the problem right, but you'll have much larger numbers that you'll have to simplify, so this is easier. All right, clearly on this last one, we're going to need a lot of work on this one. Continue to work on this one. This is where multiplying actually like this might be your instinct, okay? But the problem with that, just think about that, is yes, it'll work good there, but we'll have to simplify through to here, and then it won't work. We won't get rid of the radical. So what we actually have to do is we have to multiply by the conjugate here, okay? So what does that mean? That means, it's okay, Logan. You want to say goodnight? Say goodnight.
Yeah.
They're listening. Come here.
I'm listening.
Just say good night. Good night, buddy. All right, so times, we're going to do, that was Logan, my son, minus root 2 all over 3 minus square root of 2. All right, so look in here. On the bottom, something really nice is going to happen. We'll get to that in a second, but look at the top. Let's work through that. And then you do 5 times 3, we get 15. And then 5 times negative root 2 is going to be negative 5 square root of 2. And we're going to divide by, and now we need to FOIL this bottom. Well, here's what's awesome, and I'll work it all out so you can see this. But when you get the hang of it, you want to go faster. First, maybe I should put that in parentheses to help you out visually. First is 3 times 3, which is 9. Okay, then the outside here is a negative 3 root 2. The inside is a positive 3 root 2. And then the last is a root 2 times a root 2, which is a negative, because positive times a negative. But root 2 times root 2 is just the number 2. Well, then you can clearly see here, again, those inside terms there are gone. I can't put the top 2 terms together, so I have 15 minus 5 square root of 2 all over. And then all I have left is 9 minus 2, which is 7. And it looks ugly, but we got rid of the radical on the bottom. All right? Thanks for watching. Hope it helped.